So scientific notation is any number between 1 and 10, not including 10, multiplied by a power of 10, which sounds pretty complicated, but it can be any number. So example here, we have a 3.1 times 10 to the third power. This any number is anything between 1 and 10. So that means if it's less than 1, it's not going to work. So that way it means if it is, let's say, 0.3 times 10 to the fourth power, that is not in scientific notation. Because you have this 0.3, that's less than 1. Also, another thing that would not be in scientific notation is any number bigger or any number 10 or larger. So if you had 10.4 times 10 to the fifth power, this 10.4 is bigger than 10, and it includes 10, so it is also not in scientific notation. So for powers of 10 for scientific notation, that just means whatever exponent or whatever power the 10 is raised to. So this one right here is 10 to the third power. This is 10 to the fourth power, 10 to the fifth power, 10 to the negative first power, 10 to the negative second power, and 10 to the negative third power. So what that means and what that looks like is like this. This is 10 times 10 times 10, which is the same as 1,000. So going by that same rule, you can do the same thing with 10 to the fourth power. It'd be 10 times 10 times 10 times 10, which is 10,000. Now, you can probably figure out 10 to the fifth based on the rules from the two above, but for the other ones where it's 10 to the negative first power, that's multiplying by a negative power of 10 or a fraction of 10, so that would be 10. That's 1/10. 10 to the negative first power is 1/10, or 0.1. 10 to the negative second power is multiplying something by 1/100th. So that would look like 0.01. And if you're multiplying something by 10 to the negative third power, that's 1/1000th, which is 0.001. Now for the last section of problems that you had to do, you had a number, I'm just going to use the first one as an example, 2,479. They wanted you to round it to a single digit. And then write it in scientific notation. So if we were doing that, it would be, you would just round it to this front number. So you would look at the 4. The 4 tells the 2 to stay the same, so this would be rounding it to 2,000. But any number that's between 1 and 10 is what we have to use for scientific notation. So we are going to use that 2, but then you look and see how many places over the decimal point is. So our decimal point is really here. So to make that into a 2, we had to move it over 1, 2, 3 places. So that would look like this. Because to get our final answer, it would look, it's kind of like working backwards a little bit. So it's 2 times 10 times 10 times 10, which would get you to 2,000. And another example of that you could use, especially for like the really, really small numbers. So if they have this 0.00389, I'm going to go to my first actual digit that I see, which is here. And the 8 makes the 3 go up to a 4. So we're going to say that's 4 times 10 to something. But we're moving backwards with this. So you have to go, it would be, they want it here. So it'd be 1, 2, 3. So it'd be 10 to the negative third power. So what that would look like, and this is how I taught my students when I did this with them, that would be 4.0, and then if it's to the negative third power, you move the decimal point to the left. So negatives mean decimal to the left when you're figuring it out. So 1, 2, 3. And just make sure the number of zeros up here before your digit matches the number of zeros down here. So you have 0.00, then your first actual digit, that's a number that's not 0, and then you have 0.00, and you have your first actual number here. So since that matches up, that's correct. So that's a way for you to work backwards and check yourself. I'm going to do one more example of that because I know that can be a little bit confusing. Let's see. Let's say you have, let's do another really big number. And we have 8,466,279. Again, don't let the big numbers confuse you. We need to change it to something that's between 0 and 10 first. So look next door. That 4 makes the 8 stay the same. So the digit we're going to be working with is 8.0 times 10 to something. And we have to figure out what that something is. So we need something all the way in the millions place. So I'm going to just erase this for a second so that doesn't confuse us with the rounding. So from the millions place, it is 1, 2, 3, 4, 5, 6. So it's 10 to the 6th. And again, we're going to double check it and make sure that's right. You have 8.0. This a positive power of 10 means the decimal point moves to the right. So we're going to move it to the right 1, 2, 3, 4, 5, 6 places. Put in your zeros as needed. Take out that decimal point that we had there and make sure it matches up in terms of place value 1, 2, 3, comma, 1, 2, 3, comma. So we're going to look up here. Make sure you have 1, 2, 3, 4, 5, 6 digits before our 8. And we have 1, 2, 3, 4, 5, 6 digits before our 8. So that is how you estimate first, then write it in scientific notation. And again, if you have a very small number, you're going to use a negative exponent or a negative power of 10. If you have a very large number, you are using a positive power of 10.